Okay, so for example 3, it says, without graphing, determine what might happen with the given functions. So we have f of x equals x squared, and g of x equals f of 1/4 x. So this 1/4, going back to the previous page, we're looking at a value that's between 0 and 1. So it's actually going to be a horizontal stretch. So horizontal stretch, I'm going to abbreviate it as horiz. So horizontal stretch by a factor of 4. So it's going to be stretched out to be 4 times as wide as it used to be. Now g of x, I'm going to actually clarify this one a little bit. G of x equals f of 1/4 x. That means we're going to do, instead of x squared, we're going to do 1/4 x squared. So whatever used to be done to x, now we're going to do to 1/4 x. So f of 3, we're going to plug that into function f. We're going to have 3 squared, which gives us 9. G of 3, we're going to plug that into the 1/4 x squared. So we're going to have 1/4 times 3, and that whole thing's being squared. Well, let's clean that up in that parentheses. So we have 1/4 times 3 is 3/4 squared. Now, when we square a fraction, or raise a fraction to an exponent, we apply that exponent to both the numerator and denominator. So the numerator, 3 squared, is 9, denominator, 16. The rule for this one, again, is kind of the opposite, or I shouldn't say opposite, it's the reciprocal of what's going on in the function. So we're going to say, for function f, it used to be x comma y, but it's going to transform into function g, and it's going to be the reciprocal of what's being done to x. The reciprocal of 1/4 is 4 times x, comma, the y value does not change. So that's not going to change at all, or the y value won't change at all. Let's try one more here. It says graph both f of x equals x to the third and g of x equals 1/3 x to the third without using your graphing calculator. So the first, again, still using f of x, I'm going to use this in blue. We're going to do f of x equals x to the third, and then g of x, now using blue, I misspoke, is going to be 1/3. So it's going to be 1/3 times x to the third. Let's choose some values for x to be -2, -1, 0, 1, and 2. We're going to raise each of those to the third power. -2 to the third power is -8, -1 to the third power is -1, 0 to the third is 0, 1 to the third is 1, and 2 to the third is 8. Now this one, before we go any further, what's being done here? What's changing? The only thing that's changing is this 1/3. This 1/3 is not inside of a group with x, so it's going to be a vertical change. If it's in a group with x, it's going to be a horizontal change. If it's not in a group with x, it's going to be a vertical change. Now this one's going to be a vertical compression. So the verticals are a little more straightforward. If it's a small number, it's getting compressed. It's getting smaller. If it's a big number, it's getting stretched. So that's for verticals. Horizontals, they're a little bit backwards. So it's a horizontal compression by 1/3. So that means the x values we have already don't need to change. Oh, sorry, wrong button. The x values that we had, the -2, -1, 0, 1, and 2, don't need to change. Now we could go through and do all of the, we could do all the decimals and all that good stuff, but what I'm going to have us do before we do that is, let's do the rule here. So our x and y coordinates from function x, those will change into, and since we're doing a vertical change here, the x coordinate in g is going to be the same as the x coordinate in f, so we already wrote those. The y values are going to multiply by 1/3, 1/3 times y. So we're going to do 1/3 times each of those y values. So 1/3 times -8 is going to be -8/3, or -2 if it helps you, as -2.67 approximately, because we're graphing it. -1 times 1/3 is -1/3. That one's not too hard to estimate. 0 times 1/3 is 0. 1 times 1/3 is 1/3. 2 times 1/3 is, 8 times 1/3 is 8/3, or as we said earlier, 2.67. Approximately, we're rounding. So let's graph these and take a look at the comparison. So -2, -8, so we'll go 2 to the left, 8 down. Let's see, 1, 2, 3, 4, 5, 6, 7. Okay, that's right here. -1, -1, 0, 0, 1, 1, and 2, 8. And we'll draw this S curve going through here, just like we're driving through downtown Grand Rapids, going through an S curve. That wasn't funny. Whatever. Negative 2, negative 2 point, or sorry, negative 2, negative 2.67. So now we're going to be graphing the g of x. So we're going to go 2 to the left and then 2 2/3 down. So right about there. Negative 1, negative 1/3 is going to be right about there. 0, 0, they're going to share that point. 1, 1/3 is going to be there. And 2, 2 2/3 is going to be right about there. That one looks like it falls on the same point, but that's just my poor curve. So this one's going to be trailing behind. It's going to be a squished down, vertically squished down version of f of x.